just look at a function and I'm taking the derivative, I want to know what is the rule I'm going to start with. When I look at this, I see a product. I see 3x times the quantity x squared minus 4x to the 7. So I'm going to start by doing the product rule. A prime b plus a b prime. That's going to be my derivative. This is going to be a, this is going to be b. Here we go. Derivative of a is just 3 times b as it is, plus a as it is, times the derivative of b. Okay, now to take the derivative of b, that's going to be a chain rule situation. I've got a big power rule. So it's going to be 7 times that whole shebang to the 6th, and then times the derivative of the inside, 2x minus 4. Note those parentheses are absolutely necessary. So this is the derivative of the outside times the whole derivative of the inside. This, my friends, is your derivative. And I can simplify it in a couple of ways. If you wanted to, you could just kind of leave it as is, as 2 terms, and maybe just clean it up a little bit. There's my first term. My second term, I would just probably multiply together those 2 numbers. That would be considered fine. But as you know, sometimes when we have more than one term, we simplify by factoring. So let's go ahead and just factor to simplify this. And this is the part that often is confusing. But I have 2 terms. I'm just looking for a GCF. GCF. So this has a 3, that has a 3. I'm going to factor out a 3. This has an x squared minus 4x to the 7. This has an x squared minus 4x to the 6. So I can factor out an x squared minus 4x to the 6. Big parentheses for what's left over. In this first term, the only thing left over is x squared minus 4x. There's my plus. All right, I took out a 3, so I'm left with a 7. X. This whole thing is gone. And I'm left with a 2x minus 4. When you do factor to simplify, often the last piece is to clean up what I call your leftovers. Your leftovers are this bit inside here. So I have a 7x that I can distribute. So I have here, and I don't need a parentheses anymore around that x squared minus 4x. That's going to give me 14x squared minus 28x. And I do have some like terms to combine now. So I have 15x squared minus 32x. Now sometimes you might say, well wait, I could factor out an x from there. And the answer is yes, you could if you wanted to. You could. You don't have to. We're just kind of cleaning things up. Simplifying in calculus is a little loosey-goosey. So there are lots of options when you are simplifying a derivative. When I look at this and I think, what's the rule I'm going to start with? Well, I see something raised to the 6th. I see an outside function and an inside function. So I'm going to start with a big power rule and a chain rule. But before I do that, I'm going to first rewrite this a little bit, because this is awkward. 2 over 3x. I could make that a lot easier by just rewriting that as 2/3 times x to the negative 1 plus 5x. So I'm going to, before I take the derivative, I'm going to rewrite that. Remember, you could take the derivative of this piece when you get to it using the quotient rule, but wow, that would be confusing. Let's rewrite it first. Now I'm ready to roll. here I go. I'm going to take the derivative, starting with a big power rule, if you will, right? Bring down that 6. It's 6 times that whole thing raised to the 5th. Nothing inside changes. Times the derivative of the inside. Well, that's just a power rule now. Negative 2/3 times x to the, I'm subtracting 1, negative 2, plus derivative of 5x is 5. Oh, that wasn't that bad. And you know what? I can just leave my answer just like that. If you wanted to, you could rewrite things without negative exponents, but there's no need to do that. Positive or negative exponents are kind of interchangeable, but if you like rewriting it like this, that would be fine also. I just brought that x to the negative 1 down into the denominator. I brought that x to the negative 2 down into the denominator. Either of these would be considered acceptable answers for your derivative. When I look at this function, I think, ooh, I'm going to start with a quotient rule because I have a quotient. Remember, when you have a quotient rule, it's the derivative of the top times the bottom as it is, minus the top as it is times the derivative of the bottom over the bottom squared. In the process of doing this quotient rule, I'm going to be doing an exponent rule, I'm going to be doing a chain rule, but the overarching rule is the quotient rule. Da 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 da, here we go. So, a prime, so the derivative of the top, that's an exponential function, so it's the natural log of the base times the exponential piece as it is, and then the chain rule kicks in times the derivative of the exponent, which is 2. There's a prime times b, the bottom as it is, minus the top as it is, times the derivative of the bottom. So derivative of the bottom, that's a big power rule, if you will. So 3 times that whole shebang squared. And then the chain rule kicks in times the derivative of the inside, which is 2. And that's all over the bottom squared. Now, how to simplify this? This simplifying, again, is often the part that's most complicated. This is a rational expression. And remember, with rational expressions, the way we simplify them is usually to factor and then see if we can divide. So let's see if we can factor the numerator. I have 2 terms in the numerator. Let's go piece by piece and find a GCF. So, natural log of 3 is not in both pieces. 3 raised to the 2x plus 1, that's going to be part of my GCF. 2, ooh, there's a 2 in both. That's going to be part of my GCF. 2x minus 5 to the 3rd, ooh, I can take out 2x minus 5 squared. This is my GCF. I'm factoring this out, dividing this out of the whole of both terms in the numerator. Now, leftovers go in here. Natural log of 3 is left behind in the first term. Let's see, that was taken out. 2 was taken out. 2 of those were taken out, so I have 1 of those left. Then I have my subtraction. This was taken out. That 3 is left behind. That was taken out, and the 2 was taken out. Okay, and in the denominator, I'm raising something to the 3rd to a power of 2, so that's going to become to the power of 6. Now, I have 1 term in the numerator. I have 1 term in the numerator and 1 term in the denominator. This is just a blob of things multiplied, so I can divide. Do you see something I can divide to simplify? Sure. That's going to divide with that. So your final answer here, your simplified derivative, would be something like, and maybe I'll put the 2 up front just because I like doing that. 2 times 3 to the 2x plus 1. I don't need those parentheses, I just put them there for fun. Times the natural log of 3. I do need these parentheses. Minus 3 all over 2x minus 5 raised to the 4th. If you got this part, this derivative part, that's what's most important. That's the calculus. What we did from then on is the algebra. And the algebra is the part that tends to be the trickiest bit. The more you practice these, the more you'll get a hang of them. And they can end up being kind of fun. And always remember, what is the derivative? Oh, it's the rate at which this function is changing with respect to x. It's the instantaneous rate of change, or the slope. So always keep that in mind too. Derivatives, we're finding rates.